All right, here we have a system of equations, and it's in three variables, x, y, and z, but this first problem only has two, an x and a z. So because there's only two in that top one, we can almost think of it as an advantage, where we don't have to use this one yet, but we do have to use these ones in order to get it to look like this top one, meaning that it also only has to have x and z. So that means I need to get rid of my y's. All right, now, it's actually really nice. If I look at these two straight away, there's a negative 3y and a positive 3y. They cancel on me, so that's actually really good. And then I have x minus 2x is negative. Actually, remember, think of that as a big addition problem for those two. Right, and these bottom two together. Negative x, those cancel. 2z minus z is a positive z. Oops, positive z. And then 17 minus 22 is a negative 5. Okay? So this is also in terms of just x and z, and this top one is too. I haven't done anything with this top one yet, so I'm going to bring it down, just copying it. We have 2x plus 7z equals 19. And I'm seeing probably the easiest way to do this would be multiply this top one times 2. So I'd have a negative 2x and a positive 2x. Alright, so let me grab a different color and we'll multiply this top one times 2. If I distribute this 2 in, that would give me negative 2x. 2 times z is plus 2z. And 2 times negative 5 is negative 10. Okay, so now these two, if I add those together, the x's will eliminate, which is really good. 7z plus 2z is 9z. And negative 19 minus, or positive 19 minus 10 is 9. And that's going to give me z equals 1. Right? So once I have one variable, I can plug it back in. And I'm going to put it, I'm just going to go right to my top one, because that also just has a z and one other variable, an x. So if I take this over here and write 2x plus 7, and then instead of z, I'm going to leave that blank, equals 19. And in place of z, we're going to put 1. So just like that, we're going to have 2x plus 7 equals 19. Okay, then I'm going to have to subtract 7 on both sides. 2x equals 19 minus 7 is 12. So x equals 6. Now I have x and z. The only thing that I need now is a y. So I'm going to go back to one of my two original blue ones. And I like this middle one just a little bit better, where it says x minus 3y plus 2z equals 17. And I'm going to replace z with 1 and x with 6. Okay, so z with 1, x with 6. And so 6, simplify this a little bit, minus 3y plus 2 equals 17. 6 plus 2 is 8, minus 3y equals 17. Subtract 8 on both sides. And negative 3y equals 17 minus 8 is 9. So divide by negative 3, y equals negative 3. All right? So remember, our answer has to be in the form of x, y, z. Our x was 6, our y was negative 3, and our z is 1. So my answer, my x, y, z point is 6, negative 3, 1.